Question 9. Figure 4 shows a sketch of the curve of the equation x squared minus 2xy add 3y squared equals 50. Show that dy dx is y minus x all over 3y minus x. So an implicit differentiation question to begin with. So if we differentiate the x squared will go to 2x minus 2xy. Now we have to use the product rule on this. So the easy way to do it is to say I'm going to hold the y as a constant and just differentiate the 2x. So that is going to give me 2 and then multiply it by the y. And then what we can do is I'm going to hold the 2x and I'm going to differentiate the y, which is going to give me dy dx times by minus 2x. So we've got minus 2x dy dx. Then it's 3y squared, differentiate normally, we get 6y, and then dy dx because we differentiated y, and the 50 will disappear. So this will give us 6y dy dx minus 2x dy dx is equal to 2y minus 2x. Divide everything by 2 and factor out the dy dx, and we're going to get dy dx, lots of 3y, shouldn't have an equals there, lots of 3y minus x is equal to y minus x, and then divide to get dy dx is equal to y minus x all over 3y minus x. The curve is used to model the shape of a cycle track with both x and y measured in kilometres. The points P and Q represent points that are furthest west and furthest east of the origin O as shown in figure 4. P and Q. Using part A, find the exact coordinates of the point P. So point P here. Now we can see that this is where we have an asymptote. So the gradient is going to be undefined, okay, because we've got an asymptote there. So therefore, if the gradient is undefined, it tells us that the denominator in the fraction must be equal to 0. So for part B, what we know is that 3y minus x is equal to 0 and x is equal to 3y. So we can sub that into our original equation to have 3y all squared minus 2 lots of 3y times y, add 3y squared is equal to 50. So this gives us 9y squared minus 6y squared, add 3y squared is equal to 50. So 6y squared is 50, y squared is 50 over 6, and y as an exact value is going to be plus or minus 5 root 3 over 3. Now looking at where P is on our diagram, P is over here, so y is clearly negative, so therefore y is equal to negative 5 root 3 over 3. And we want to find the x value, so we plug that in, and we just get negative 5 root 3 when we plug the x value in. So the overall coordinates of P are going to be minus 5 root 3 and minus 5 root 3 over 3.